Okay, good evening, students. I want to quickly solve this assignment or question given. It says the ultimate design moment to be resisted by a section is 185 kilonewton. You have to determine the area of the steel required, given that FCU equals to 25 Newton per mm squared, Fy as 410, and B is 225 and D is 440. Okay, so what I'll do is let's scroll up and see how we can solve this. From our code, all we just have to do, everything has been given already. The question is straightforward. Everything has been given. So all we just have to do is start solving immediately. From the BS code, where we have K prime equals to 0.156. And here we have a condition that says if K is less than or equal to K prime. But the question is, where is our K? Our K is here, given as K equals to M over BD squared FCU. So I'll come here and write solution to question number 1. So we have been given B, we have been given D, FCU has also been given, then we have our Fy also given. So let's quickly substitute that. B is 225 by 440. This is 225 mm by 440 mm. Fy and FCU 25 and 410. This is 25 Newton per mm squared and 410 Newton per mm squared. Our moment is 185. I have moment equals to 185 kilonewton meter. So from my K, which is equals to M over BD squared FCU, this will give me 185 times 10 raised to the power of 6 divided by 225 times 440 times FCU, which is 25. So let's quickly bring out our calculator. Okay, so from our calculator we can just quickly get this. This is 185 exponential 6 divided by 225 times 440, then times, okay, don't forget here should be 440 squared. That's 440 squared. So I'll go back to the calculator and say this is 440 squared. Okay, then times 25. So, and that is equal to 0.169 approximately. That is 170. 170. So if that is the value of our K, we now need to go to our code and check what that stands for. According to this code, it says if your k is less than k prime, then of course we know that our k is greater than k prime, because k prime is 0.156. So I'm going to go to this version. So compression reinforcement is required. So I'll now say since k prime, which is equal to 0.156, is less than k, which is equal to 0.170, therefore compression reinforcement is required. So if it's required, we go back to the code again. What is our code saying? Our code says we go and get our Z. And what is our Z? So Z now equal to D into 0.5. Okay, 0.5 watts. 0.5 plus 0.5 plus square root of 0.25 minus k prime over 0.9. Substituting this will give me D, which is 440 into 0.5 plus square root of 0.25 minus, remember our k prime is 0.156 over 0.9. Once again, you bring out your calculator and calculate. So we have 440 bracket open 0.5 plus square root of 0.25 minus 0.156 divided by 0.9. So we close the brackets. So I'm getting 341.83. 341.83. Okay, we've gotten our Z. Let's go back and get what the next thing. The next thing is for us to get the X, but I will not do that. I'll move and get the AS prime, which is for the compression zone. So I'll quickly and bring it here. Okay, so with this now I can now say my AS prime equal to K minus K prime into FCU B D squared all over 0.95 Fy into D minus D prime. But in this question, D prime is not given, so it's good to save on assumption. We're going to assume that our D prime to be equal to 50 mm. So from here now I'm going to get our K. What is our K again? 0.17, 0.170 minus 0.156 times your FCU. FCU is 25 times 25 times B, which is 225 times 440 squared. Everything all over 0.95 times 410, that's 410, times bracket open 440 minus that is 50. So we can also solve this straight away to get our value. So let's bring forth our calculator. Brackets open 0.170 minus 0.156, close the bracket. We have times 25 times 225 times 440 squared. Okay, then we have 0.95 times 410 times bracket open 440 minus 50, close the bracket back, and we have 100.37 mm squared. So we are going to look at the table that was given, or we'll call it a steel selection table. So if we take a look at the table, we notice for 100, if we are on an assumption that we are using 16 mm, how many are we going to use? So from table A, in the table that is given to you, table A, if I decide to use 2 of 12 mm, that will give me 226, and that is what I'm going for. So I'm going to say provide 2y 12 mm, and the area there is 226 mm squared. If you notice, my selection is greater than the AS prime, so this one will be for the compression zone. Now let's go back to, so the next thing, we have done that of the AS, so we need to do that of the, we've done AS prime, so we need to do that of the AS. So I'm going to copy this. So let's see for one moment again what that is K prime, that means. Okay, so I'll now come here, my AS equals to brackets open K prime FCU BD squared over 0.95 FYZ. Then the bracket, we should have a closed bracket here, so I'm going to close this bracket plus the AS that prime that we got initially. So I'm going to come here and substitute my value 0.156 times BD. Sorry for that, I'm going to clean that up. I'm supposed to insert value. Our B is 225 times 440 squared all over 0.95 times 410 times, what is the value of our Z that we got earlier? 341.83. 341.83, then plus our AS, which we got as 100.37. So let's solve this also. I'll bring up my calculator 5 here. So let's go back to our calculator and add 25 here. So I'm going to say times 25. Good. So we clean up this one. This is wrong. We have it as 1376 1376.32 mm. So if we take a look at our table again, let's take a look at our table. 5 will give me, so I'm going to say provide 5y of 20 mm, and the area there is 1570 mm squared. Okay, so another person can decide to provide y25 depending on what you really want. So that is the end of problem number 1.